Hey, what's going on, folks? It's Mike here, and welcome back to the SDL2 C++ programming series. In this lesson, we're going to revisit a topic that we have talked about previously, fonts, and how to draw text in SDL2. But this time, we're going to adjust it and just make our code a little bit more easy to work with by building a class for our actual text. So, as a recap, I will link in the description below the previous font video on true type fonts so you can see how to get set up with the SDL TTF library if you need that. Otherwise, let's go ahead and review that code quickly and then build an abstraction into our framework so we can use fonts easily. So what I've got here is the previous lesson. This was lesson 14 before, and we can see how we compiled here, linked in the SDL2 TTF library, included the appropriate header file for our system, wherever that header file is located, and then we did some of the setup. So in order to create a font, we had to do a few things, and this is why we're going to build a little class to make working with fonts easier. We initiated the TTF library just to make sure that was found, the library was set up and everything. Then we're able to load a font and specify the particular font size for that font, and then confirm and do a little bit of error checking that this font was indeed loaded. Then we had to do some work to render that font to an actual image, and then eventually we wanted to render that text onto a texture. Now, again, the purpose of this is that rendering textures and storing the text in video memory is a lot faster. So this was our overall goal here. Then we wanted to free the surface because we don't need it anymore once we have loaded everything into the GPU. And then, of course, we displayed our actual texture here, so we had a method for drawing our text to the screen. And then finally, some cleanup, destroying the texture and destroying our font. So that's, again, a lot of different steps that we had to run here. And if I go ahead and compile this, here's the pure command line on my Linux machine, and run it, we had something like this that showed up here. So we know that it works and so on. So now we actually want to build a little bit of an abstraction with this code here. So what I'm going to go ahead and do is leave this open here, but I'm going to go ahead and jump into our next project, which is going to be in this folder here where we have a build file. So I'll need to modify the build script that I have provided here to make sure that we include the SDL TTF library here. Make sure that that's being linked in. So I'm just going to add that here, -L for linking in the library, SDL2_TTF, and then a space here. So now we should be linking in that appropriate library. And we're also going to need to make sure that we include this new font library here. Now, let me go ahead and create a new file. And perhaps it'll be easiest if I just open this in another window or another terminal so that we can refer to it, and then I'll keep this open. So let's go ahead to the font class here, and just again, as a reminder, here is our program structure, just so that we can see what we have here. And we are going to want to add a folder here as part of our asset for those fonts here. So allow me to just open up another terminal window here. And what I'm actually going to do, just to make it really distinguishable, is just put this in a totally different color here, just so you can see the font code from the previous lesson here, which we might borrow from, and then the new project that we're working on the left side of the screen here. So again, let's go ahead and navigate into the SDL tutorials, the fonts here. And if I cd into that fonts directory, you'll see we had at least this one font that was loaded here. So what I'm going to go ahead and do is just back out of this and then copy my fonts folder here. And I want to copy the entire thing. And let's go ahead and set the destination to be lesson 29 in the assets directory. So if I list this out here in the assets, we now have our font copied over. And again, if you're following this, you'll already have the actual fonts set up. You can just download from the repo, as always, if you need. Okay, so now that I have that, I just want to keep the code open as a reference on the left side here. I'll make it a little bit smaller so it's less distracting, but let's go ahead and start implementing our font class here. So in order to do that, what I'm going to need to do is open up a new file here, and I'm just going to call this text for now. and I'll call it text HPP. And this is going to be a file that I need to set some header guards up for. And since I called this text, I'll just call it text HPP and define HPP and endif. And let's go ahead and make the class here, and I'm just going to call it text. Now, text itself probably isn't a super great name right now because it's likely that object name could be made. So at some point we may want to consider, for example, if we should put this in a namespace, but that can be something we worry about later on if we start including more libraries. Anyway, so I'm going to have some constructor, and then I'll have a destructor. Now, as you've probably seen me do in my other videos, especially if I'm quickly building something up for the purpose of this tutorial, I'm just going to put everything into the header file for now, and then I'll sort things out and move into the implementation later on. But let's just see what parts we need. So we know that we definitely need the TTF library here. So what I'm going to go ahead and do is copy this, because I know this is the path where I need everything. And I'll paste that in here. This is the SDL2 TTF font library for drawing text. And let's go ahead and see the other components that we're going to need here. Now, one thing that we need to think about here is, are we actually going to need some sort of manager class for our fonts? What if we load a bunch up? And in fact, the way I'm going to design this class for now is going to be a little bit inefficient in the sense that I'm going to repeat some of these steps here. But for now, what I want to do is just have this TTF init function called somewhere within our constructor here. And we only truly need to do this one time. So maybe I can make this some sort of static check, or there's functions in C++ checking to make sure that something is called once. For now, I'm just going to keep this all at, or rather just keep this whole chunk of code as part of our constructor here. Again, maybe I want a sort of static variable or something that just calls this once. I could do that. Maybe I'll change my mind by the end of this video, but for now I just want to get something up and running here. So in efforts to make this a little bit easier to copy and paste here, let me just go ahead and grab our code as such here. So let's just go ahead and paste this in here. And again, I have a little bit of error handling code here with the standard out. So for now, it's okay to include the IOStream library. Again, we'll probably want some sort of logging mechanism if this is a more professional game engine, for example, rather than just having IOStream right out to our standard output. In fact, we could write out to CArr or some of these different things here. And for the purpose of this lesson, I'll leave in the comments as well, because I think it's a nice reminder for what we've been working on. Now let me make sure that this is set up here. All right. And I want to just make sure that the indentation looks correct here. Okay, and as I am looking at this code, I think it probably is appropriate to actually just have some sort of static here for calling this function one time. And there's actually something neat in modern C++ that we can use, this call once function that basically just has some functionality for calling things one time. So we can actually, within this function here, have a flag here and then just call some function. I'm going to do things a little bit simpler with just a static variable here. And I'll make it private. And I'll call it TTF. And it's going to be a static variable, so I like to prefix with S here. TTF initialized. Okay, so something like that will be fine. And we'll have to make sure that this particular static variable has some initial value here. Because it's static, again, if you need to read up about static, I'll have some videos on that on my C++ series. But basically, this means that the static variables are allocated with the executable, so they need to have some sort of default value so they know what to put in them. Okay, and then this class here, text, any instance of it is going to share this value, whatever it happens to be. Okay, so with that said, that's a little bit of a hack here, and then I'm going to go ahead and change this variable here. TTF initialized equals true. So let me add a comment because that's a bit of a weird design thing here. Let me skip here. Just fix this formatting. It's still a little bit wild here. And let's go ahead and say initialize TTF system only once, even if we have multiple text objects here. Okay, so that's the idea. Again, we can improve on this design. Our idea now is we just want to be able to draw lots of strings in our actual SDL programs. Okay, so what are the next things that we need to do here? Well, in my destructor, let's go ahead and, since I have initialized the system, let's see if we need to do any sort of shutdown. And that will just be for our actual font here. So I'll keep that in mind. Let's go ahead and start creating an actual font here. Okay, so what we set up next here is, well, here's all of our sort of loading of the font code. And I'm just going to grab all of it. I'm going to plop it into our constructor here. And I'll just go ahead and clean up the formatting. And I'm actually going to grab some of this other code here for freeing the actual surface, and I'll paste that in as well, because once we have created our text, we can be done with it. And let's go ahead and just indent that. All right, and what are the cleanup steps that we need here? Well, we need to be able to destroy the texture and destroy our font here. So let's go ahead and set that up in our destructor. So I'll paste this in and destroy our texture. And maybe line them up so that they look a little bit nicer. And then at this point, what I'm going to do is also give us the rest of the logic that we need in our system, and that's going to be to draw the text. So I'll just create a void function to do that. And let's go ahead and take a look at what we needed to do here. Well, we simply just needed to render on some sort of rectangle the actual text here. So that means we're actually going to need one other piece, which is the actual rectangle, which is called the, well, just rectangle in this code here. And let me make sure to close these parentheses here. And let's go ahead and set that up here. So here was our rectangle that we were drawing on here. Now I'm just going to move this into the constructor for now, and then you're going to see me do a little bit more refactoring here, because we're actually going to need some member variables or to convert some of this code rather to have these locally declared variables as member variables in our class so that they persist here. Okay, so we've got that set up here. Okay, so with that said, let me go ahead and exit this, and all I'm going to do at this point is just see if our code builds and see if we need to fix anything. Now I'll need to include the SDL library, which this is my directory. It might be different for you if you have a Mac, but mine's an SDL, SDL.h, SDL2. There we are, and let's go ahead and just see if this builds. So with that said, very lucky, since we're sort of copying and pasting from some code that previously works, it does in fact build. Okay, so I think I've got all the components that I need here for our text system, and maybe we'll have to do a little bit of debugging, but for now, this lesson code has done its job, and now we can apply our further abstractions. Okay, so now what we need to do is work with our constructor a little bit. And what I want to do is go ahead and just modify our code here. Let's see. Now this will short circuit. So if not STTF initialized, then so if this is false, then we will run this, and then we will check if our system initializes. It'll give us an error message. Then we'll flip this flag so that we don't have to do it every time. We have the font that we want to load here and the font size. So these are looking like parameters for our constructor. So what else do we have here? Then we have our actual surface text. Now, again, how I'm designing this class for now, just to make it easy to plop a few bits of text into our code just through one object, is we probably would, again, want a separate class to manage our fonts and then something separate for each of these surfaces that we're drawing onto. In fact, we're going to have to think about this a little bit, such as, do we want to be able to change the actual text that one of our text objects is rendering on? That is the actual string here. That is some consideration that we will have to think about here. For now, let's just assume that it is static, but if we do want to change it, perhaps towards the end of the video, I'll work on that feature here. Okay, so here is the other interesting portions, I guess, of our text object here. This R font member variable here, which is this guy here. And this is something that's going to be a member variable. So I'm just going to refactor our code here a little bit and substitute R font and make this M_R font and do a substitution. And then I'm going to grab this here and just make it a member variable. Okay, so this is just some of the refactoring that goes into taking a bunch of code and then turning it into some sort of class here. Okay, let me paste this in. There we are. Okay, so the other pieces that we had were the texture text and the rectangle. So we're going to need our SDL rect. Here, rectangle. And we're going to need a SDL texture, texture, and an SDL surface. SDL surface, surface. So I'm just going to go ahead and refactor each of these here. Okay, and just make sure that these are pointers so that they match what is expected from the SDL API when we're creating a new surface or a new texture. Okay, so at this point, we have some interesting text here that we are perhaps rendering here. Mike SDL series will worry about parameterizing that in a few moments. And we do have to deal with this renderer here that we'll have to think about. That is where we're actually creating this and rendering things. Now, again, here's sort of the design decision that we have to do. We could make rendering text a expensive operation, meaning that the text is able to change easily. And essentially what we'd be doing is constantly deleting this surface, recreating it, and texturing it. So maybe one way to think about this text class is as dynamic text. And for now, that's how I'm going to relabel it. Again, this is something that was sort of on my mind, and this is why we tend to sketch things out in paper a little bit, so you don't do a lot of code decisions. But this is also why I'm just doing everything quickly in the header file, so you can see me sort of make these different changes. So with that, I'm going to actually change everything to dynamic text here. And I'll even put a warning here, or a sort of how this is expected to be used here, which you'll often see folks do. Dynamic text objects can change, but they are more expensive to use because the textures are constantly recreated each frame. So this is going to be relatively inefficient, but for now it'll be good enough for the use case that we have here. Okay, so let's go ahead and get to the point here. So what I wanted to do then is I'm going to go ahead and move all of our creation and configuration things that we are doing into our draw text here. Because every time that we draw the text, we are going to need access to whatever the SDL renderer is, the actual surface. We'll free the surface every frame, and we'll actually have to, well, I guess we won't have to destroy our texture every time. We'll just be copying to it. So that can be just allocated once. So I think that'll be okay here. Okay, so with that said, our dynamic text, let's begin parameterizing this. And the one thing I actually want to do before I get too far ahead is just move this file text, let's see, move text HPP and call it DynamicText.hpp. Just so that it aligns with what our class name is, again, just to sort of best practice here. Okay, so now we have this dynamic text. Let's go ahead and provide a, this would be a string here to this actual path here. And I'm just going to copy this string so that I have it. So let's see, example. Let me just save that string here. And this will be the font file path. And this should be some font size. Now these might be member variables that we want to store somewhere, or again, look up in a resource manager. Again, those are things that you can add on and watch the resource manager video, which I'll also link in the description if you want to just see how that is done. Okay, so let's go ahead and provide these parameters here. So again, making our code a little bit more flexible so we can have different fonts. It's the font file path, and this is expecting a C string because this is a C library. The font size. All right, and then we'll check if our font was initialized. Our destructor will do the destroying that needs to do. And then our text drawing routine is going to need the SDL render. And it's going to need that as a pointer that we'll have to pass in. And then let's see, what else should we provide? Probably the X position, the Y position. We could also do the width and the height. The width and the height. And then also the string. For now, let's just constrain ourselves to the text is always a white color. Again, in this sort of framework that we have, we might want to almost copy the SDL way of doing colors and have a sort of set render color or a foreground color. Various APIs will do these kind of things. Let's just constrain ourselves to white text for now. And then let's actually pass in the string here. Let's go ahead and pass in a string object. Now, of course, SDL is going to expect this as a C string. So we'll have to convert this to C string. And there we go. Okay, so let's go ahead and it's been a while since we've given this a compile. Certainly there have been some mistakes made, so let's go ahead and see what those might be. And, well, I've unjinxed myself because there's no mistakes, which is quite rare here. So we'll just appreciate it for what it is here. So in order to use or test this out, let me just show you with what we're starting with here. Now this is from a previous lesson here where we had the collisions here, and maybe you'll hear them on the microphone or maybe not. But let's just go ahead and see if we can draw two text objects and see if that works. Okay, and we're going to do that in our main function. And because we're drawing text and potentially updating it every frame, well, what we're going to have to do is put this somewhere in our render or maybe an update function. Because we're doing stuff with the render, it'll make sense actually to put this in the render. So I'm going to need my constructor here, this file path, and then to call the draw text function here. Okay, so let's go ahead and split our view here. Let's go ahead and find out where our main is. Here it is. And let's go ahead into one of our event handlers where we're doing our rendering here. And let's go ahead and see if we can use our dynamic text here. Okay, and actually the problem might be that we need to include this. Maybe that's why we're not getting any errors. But let's actually try to use it. I'm going to go down to render here. And typically in games, we render the text after drawing the objects because this is going to be part of our user interface. So that's why I'm going to do it in this order where I render all the objects first. Now, perhaps in a future lesson, I'll have to talk about how we can assign objects or text to different layers, and we can have sort of a layering system, but that'll have to come in a future lesson. Okay, so this is the moment of truth. Dynamic text here. And let's just call it text1. And we need our file path and a reasonable font size, which I'm just going to copy from here. And let's just go ahead and paste that in. And then, of course, so we're going to create this and expensively redraw it every time. So again, that might be something we want to change, or we might want to create a static text sort of function, I suppose. Either way will be okay. Okay, so our function here, draw text. We need to get the renderer, so we had to do that through SDL app here, which I'll have to look in our main just to see how we called it, just app here. And we have the function get render, so I'll just copy that here and paste that in. And let's try Mike SDL2 series again. X position 0, Y position 0, the width 400 by say 100. And let's go ahead and give this a compile, and now we will cross our fingers and see if we get some compilation errors anywhere in this code. Oh, just one here. Darn, I thought it was going to be the perfect lesson. And, oh, it says, yeah, we do have to fix this few errors here now that we're actually getting compiled in. A little bit surprised that didn't pop up. Dynamic text here. Let's see what else we got up here. A couple other errors. The renderer here that's being passed in. For some reason, it thinks it's a int pointer. So let's see if I just messed up the arguments on this side. Looks like this should be a underscore. So I'll go ahead and fix that up. And let's see what other errors we have. Looks like that was one that propagated a bunch, and my destructor is still called text. So I'll go ahead and fix that up. Okay, a reasonable amount of errors to be expected, so I fixed a few. Let's go ahead and rebuild. And let's go ahead and see what happens. All right, so now the big question is, does our program actually work when we run it? Okay, could not load font. Okay, so we'll have to think about where this actually is, and that's kind of good that it closed. Now this is in the assets folder again. So if I do assets, fonts, and then our actual font, so that appears to be the error. So as always, we'll just rebuild and see if we get a better result. All right, let's try to give this a rerun. And just like that, our text is now rendering. Now, we're not quite yet done because I want to try to do a few more interesting things. Behind the scenes, I'll go ahead and split this into a separate implementation file so you don't have to mess around with that. That means a separate CPP file. But I want to see if, one, can we draw multiple texts here? So let's go ahead and create text2, and let's just render this somewhere else. And again, just to make this a little bit more interesting, let's make this a smaller font, say 16. And we can draw something else. So let's just call this test. And this will be text2. And we'll go ahead and rebuild this. So if this works, this is a pretty good sign that our text is actually doing its job, or the purpose of this class here. Actually, let me, before I do this, let me change the position here. Let's move it to like 400 by 400. How about that? See if that fits within our window. So anyways, I just wanted to make sure that we can actually, again, draw two pieces of text in our program. Oops, we're getting some sort of weird error. So let me see if I can actually move test here. I believe the actual problem now is that we're just not reassigning the value of our actual rectangle here. We're not actually using any of these values. Okay, so that's one bug that has been caught. X, Y, W, and H. And that's why we do multiple tests. The third test that I want to actually do after this, assuming the position works right, which we'll find out in 1 second, which looks like it is, that's great news, is actually see if we can update the text here. Meaning that, well, the trouble that we went through to make this dynamic text means that we're regenerating every frame because it might be changing. Okay, so let's see if we can go ahead and do that. So I'm just going to adjust the positions here just a little bit to make them a little bit more reasonable here. Let's go ahead and create a third text. And for this one, what I'm going to do is just pass in some number here. Let's make the X position 2 here, and I'll just create a static int counter plus plus, something like that. And let's just go ahead and do std to string counter. Let's go ahead and see if that does the trick here. And if that works, then we're essentially done and we'll have a handy font class available for us. And looks like it's relatively working. Although the font sizes I'm not 100% convinced are working, so I just want to do a quick look at that. But the good news is we do see that the counter is incrementing here. So let me go ahead and scroll up to our constructor here and make sure that the font sizes, let's see, and I guess the rectangle size, I guess the width and the height would need to be adjusted here. So actually, let me make these a little bit smaller here. That's likely the problem. 50, something like that. And we'll make this one also a bit smaller. All right. One more build, one more test. And again, we sort of position things in random locations here. I guess I didn't change the this guy, the actual size, so it's overlapping. So let's just make this 50. Yeah, this one's going to be a little bit wider, but how about 50 by 50 here? And I'll position this at about 50 here, towards the start of our screen here. Okay, one more test because it's kind of interesting and fun to play around with. So you should be able to take this code, play around with it a little bit, again, with the different font sizes. Maybe there's different things that you could add. For example, you can probably make this code more efficient, meaning that, you know, maybe there's something in here, actually taking a quick look, you know, I don't need to free this surface. Maybe I could just, you know, maybe do something more efficient here. I need to think about it just a little bit, but you get the idea of having a font class here. But other things that you'll often want to do is maybe fit the font size dynamically to a space, and you can kind of do some of those calculations ahead of time. You can align the fonts left, right, or center, or experiment with some of these different features so that your system works more cleanly or aligns with other systems that you're used to using, whether those other graphics systems or layout languages. So with that said, we now have a font class, easy way to render text, and that's going to help us as we move on to our next projects. All right, folks, I hope you enjoyed this lesson. I hope you enjoyed creating a font class. And well, here it is. And it's pretty cool to actually see it in action and working. And again, this is going to help us power up some of our other applications. And when we start building some games, you know, we should have some output to the player through SDL and not the console. So if you enjoyed this lesson, and especially if you made it this far and you haven't subscribed yet, make sure to subscribe so you don't miss any of the other lessons. Or if you just enjoyed the video, just go ahead and hit the like button down below. All right, folks, we'll see you in the next lesson super soon. Enjoy.